In this lecture, we are going to discuss some problems, basic level problems, how to calculate pH. Okay, so here first we discuss very basic level and then we discuss somewhat higher level, that is level 2 problems, and then we discuss some difficult problems also. Okay, so in this lecture, so we discuss some simple problems. Okay, so calculate pH of the following aqueous solutions at 25 degrees centigrade. Okay, so here they have given some aqueous solutions and we have to calculate the pH for those solutions at 25 degrees centigrade. Okay, so now first solution is 0.05 molar HCl. Okay, so for this solution we have to calculate pH. Okay, so here first you should check in the any pH calculation concentration should be expressed in normality. Okay, not in the molarities. Okay, so here first that you should check. Many students make mistakes there. Okay, directly they will substitute the concentration in terms of molarity only. Remember that you must express concentration in normality only. Okay, so here for HCl, what is the formula to calculate normality when molarity is given? Normality equal to molarity into n factor. Okay, normality equal to molarity into n factor, right? Okay, so for HCl, what is the n factor? 1. For HCl, n factor is 1. So here, normality equal to molarity how much? 0.05 into n factor is 1. So that is equal to 5 into 10 power minus 2 normal. So no, 0.05 we can write as 5 into 10 power minus 2. Okay, and this is the concentration of HCl for strong acids. We discussed in the previous lecture, acid concentration is equal to concentration of H plus ions. That is equal to 5 into 10 power minus 2 normal. What is the acid here? HCl. General condition I am writing. Okay. Or if you have confusions, you can take in this way also, no problem. Concentration of HCl equal to concentration of H plus ion. Okay, so this reason already we discussed it in the previous lecture. Okay, so this is very useful while solving the pH problems. Okay, so now what is the formula to calculate pH? pH is equal to minus log H plus ion concentration expressed in normality. Okay, so this is the formula to calculate pH. Okay, let us substitute this H plus ion concentration here in this formula. Minus log 5 into 10 power minus 2. So no. Now see, this is in the form of log A into B. That we can write log A plus log B. Yes or no? So minus of log 5. So here minus log 10 power minus 2. Yes or no? Actually here we get minus of log 5 plus log 10 power minus 2. Here we have minus, so if you multiply minus into plus minus. So minus log 5 minus log 10 power minus 2. Okay, so log 5 how much? Minus 0.6990. Okay, we have to remember log 2, log 3, log 5 and log 7 values. So here sometimes they will provide in the examination and some other times they are not providing, so better remember. So log 5 is 0.6990. Here see, the log 10 power minus 2, this minus 2 comes here, right? Minus into minus, that will be plus 2. Now we have log 10 base 10, so no, that is equal to 1. So this minus 2 comes here, minus into minus plus 2, log 10 base 10 equal to 1. So that is no need to write. Now 2 minus 0.6990, pH is equal to here 1.3010. Okay, so this is the pH of 0.05 molar aqueous solution of HCl at 25 degrees centigrade. Okay, so first thing, what is the first thing? Check that concentration is whether given in the normalities or molarity. If that is given in the molarity, convert into normality by using this relation. Okay, and then pH is equal to minus log H plus ion concentration expressed in normality and substitute. After simplification we are getting this value. Okay, now let us see this one. So here 0.05 molar H2SO4. Okay, see, look at these two. 0.05 molar H2SO4. This is 0.05 normal H2SO4. Okay, so in both cases we get different answer. Let us see. Normality is equal to here how much? Molarity 0.05 into n factor is 2. Okay, so here we have already formula. So normality equal to molarity into n factor. For H2SO4 2, yes or no? Because H2SO4 has two ionizable hydrogens or replaceable hydrogens. Okay, so that is nothing but n factor for the acids. Okay, so that's why here two ionizable hydrogens are present. So n factor equal to 2. So this normality will be equal to 0.1 normal, that is equal to, we can write 10 power minus 1 normal. Okay, so therefore concentration of H2SO4 is equal to concentration of H plus ion, that is equal to 10 power minus 1 normal. Okay, so now if you substitute in the pH formula, here already we have the formula, minus log H plus ion concentration is 10 power minus 1. Okay, so this minus 1 comes here, minus into minus plus, so pH is equal to 1. So no, then log 10 base 10 equal to 1, so that's why minus 1 comes here, minus into minus plus, that is equal to 1 pH. Okay, now look at this solution. See the difference between these two. Here concentration is given in molarity, here concentration is given in the directly normalities. There you should be very careful. Okay, so here directly we can use this one, yes or no, given in the normality, but here molarities is given, so that's why first we converted to normality by using this relation. Okay, so here concentration of H2SO4 is nothing but concentration of H plus ion, because it is a strong acid, that is equal to 5 into 10 power minus 2 normal. Okay, 5 into 10 power minus 2 normal. So here therefore pH is equal to minus log 5 into 10 power minus 2. This already we simplified here, yes or no? Minus log 5 into 10 power minus 2 will be, the final answer is equal to 1.3010. Okay, see the difference between these two. Same H2SO4, 0.05 molar, here 0.05 normal. So we get different pH values. Okay, so that's why you should be very careful here whether the concentration is given in the molarities or normalities. Okay, clear? Right. Next, 0.05 molar NaOH is given. Okay, so here also concentration is given in molarity, in the normalities 0.05 into 1, because n factor for NaOH is 1. So that is equal to 5 into 10 power minus 2 normal. Okay, 5 into 10 power minus 2 normal. See here, now concentration of NaOH is equal to concentration of OH minus ions. Yes or no? Because it is a base. So already we discussed in the previous lecture, concentration of strong acid equal to concentration of strong base is equal to concentration of OH minus ions. So that is equal to 5 into 10 power minus 2 normal. Okay, so here we get, so we have OH minus ion concentrations, means first we should calculate POH, that is equal to minus log concentration of OH minus ions. Okay, concentration of OH minus ions expressed in normality. Okay, so this is the formula to calculate POH. Okay, so if you substitute here minus log 5 into 10 power minus 2. Okay, so that is POH is equal to, so already here we simplified, right? Minus log 5 into 10 power minus 2. Here also same, we get POH equal to 1.3010. But we have to calculate pH. Here you should be very careful. Okay, so generally many students makes mistake here. In the problem they ask you to find pH, when base is given, first we calculate POH. Yes or no? After calculating POH, we are calculating pH. What is the relation here we use? pH plus POH is equal to 14. Okay, pH plus POH equal to 14 at 25 degrees centigrade. Yes or no? So from this we get pH is equal to 14 minus POH, that is 14 minus 1.3010. Yes or no? This relation also already we discussed. pH plus POH equal to 14 at this temperature. So pH will be equal to 14 minus POH. So here pH will be equal to 12.6990. Okay, 12.6990. Okay. So here when base is given, here also you should be very careful. Many students make mistake here. Okay, don't attempt in the examination. Observe carefully whether they ask you to calculate pH or POH. For bases, if POH they ask you to calculate, we stop here. This is the answer. If they ask you to calculate pH, this is the answer. So no, pH equal to 14 minus POH. Okay, now let us see some other problems also. Now let us see another problem. 0.01 moles of H2SO4 present in 100 ml of solution. Okay, so here concentration is not given. They have given how many moles present in the 100 ml of solutions. Means first we should calculate concentration. Yes or no? So when number of moles is given, the formula, see this solution, this can be solved in two ways. Both we discuss. Okay, so method 1, molarity is equal to number of moles by volume in milliliters into 1000. So no, because volume is given in milliliter. Okay, so if you substitute here number of moles 0.01 by volume is 100 into 1000. Okay, so this 10 times 0.01 into 10, molarity is equal to 0.1 molar, but we need normality, so no, concentration. So therefore normality equal to molarity into n factor. Just now we discussed. So 0.1 into 2 for H2SO4 n factor is 2. Already we discussed it in the previous problem. So this is equal to 0.2. Okay, so therefore concentration of H2SO4 in normality is equal to concentration of H plus ion, that is equal to 0.2 normal. Okay, so now therefore pH is equal to minus log H plus ion concentration, so that is minus log, this we can write 2 into 10 power minus 1. So no, 0.2 we can write it as 2 into 10 power minus 1. So now see, this is in the form of log A into B. So this we can write minus log 2 minus log 10 power minus 1. So no, minus log 2 minus log 10 power minus 1. So that is here, this is minus 0.3010. So no, log 2 equal to 0.3010 plus 1. Okay, this minus 1 comes here, that becomes plus 1. So therefore pH is equal to how much? 1 minus 0.3010, 0.6990. This is the pH for this solution. Okay, so first we have calculated concentration from using this one. Yes or no? Given number of moles is given and volume of the solution is given. Okay, so from this we are calculating the pH. This is first method. Next, second method. In another way also we can solve this. That is, so here number of moles is given, but we need concentration in the normalities. What is the formula? Normality equal to number of equivalents by volume in milliliter into 1000. So now this is a direct formula to calculate normality. Okay, and here we know that, but here number of equivalents is not given. They have given number of moles. So Gen is equal to number of moles into n factor. Okay, number of equivalents equal to number of moles into n factor. So here, therefore, normality is equal to number of moles. How many moles? 0.01 moles into n factor equal to 2 by 100 into 1000. Okay. So normality is equal to 0.2, that equal to 2 into 10 power minus 1 normal. Okay. See here. From here onwards, same story. Write the pH formula and substitute. We get the same answer. Yes or no? Here also normality we are getting 0.2 normal. Right? And here also we are getting 0.2 normal. Okay. So you can proceed in any method. First by calculating molarity and then calculate normality. Okay. Next R. Direct normality formula is number of equivalents by volume in milliliter into 1000. So but here number of moles given. So this is the formula to calculate number of moles into number of equivalents. Okay, whatever it may be, you must know. See, n factor wherever you go. So that is very important. Yes or no? N factor, we must know how to identify the n factor. Okay. So once if you find the concentration, then simple. Substitute in the formula. Okay, clear?